All right. Hi, everyone. Hello. Am I audible to all of you? Awesome. Great. How is everyone doing? Excited to start arrays today? All right. Great. Chalo, let's quickly get started. The schedule everyone know for this week, right? TTS. I believe some people were asking. So I thought I will inform. Sunday, most probably there won't be a class. Next Sunday, there will be a class. Okay. So Tuesday, today we are doing arrays 1. Then we are doing arrays 2. And by the end of this week, we will be completing 2 pointers. Okay. That is what the overall objective is. Okay, then let's get started very quickly. Give me a second. Okay, so today what we are going to do is we are going to start with a very new topic, which is going to be called as arrays. Okay. First, we will understand the use case of arrays, right? Whenever we start a new topic, we'll first understand why do we really need this, right? What was the request, right? Or what was the reason why we had to come up with something like arrays? And then how does array really make our life easier? Just a humble request, ma'am, when sharing, kindly share the topic name as well. Tawfiq, I did share. If you will see the announcement section, I messaged on that. Please join for the session on arrays. So the topic name was mentioned. Okay. Okay. Moving on. So far, let's say you have to store some information, right, related to anything possible, right? The only thing that we know so far which can hold information are basically variables, right? There are different types of variables, and different types of variables are basically able to hold different types of information of different types, right? But this solution is not very scalable. Let's take an example. For example, I have to store the name of the students in a class, and there are 50 students in the class. Based on what we know so far, what I will have to do is, I will have to essentially create 50 variables to be able to store all this information. It could be name 1, Rahul, name 2, Ajay, name 3, Akash, right? So this is how I will be able to store the name of 50 students by using variables, right? Now, there are multiple issues with this kind of an approach. The first issue is this is a lot of redundant code and a lot of code that you will have to write, correct? Secondly, there will be too many variables, right? And it is not possible to remember all the names of all the variables, right? And thirdly, what we can also see over here is this kind of a solution may work, for example, in case the class only has 20 students or 30 students, right? But this solution will definitely not scale at all in case we have, let's say, 1,000 students, or let's say I want to store the student names in the entire university, right? So in these situations, when we want to store a lot of data, which is of similar type, right? Here, I want to store the name of all the students, and I know the name of all the students are always in the form of strings, right? When I have to store a lot of data and that data is of similar type, we actually use arrays in those situations, which kind of come up and kind of solve all the problems that we just talked about that we come across in variables. Okay. So that is why we had to come up with something like arrays, which is nothing but is a collection, right? What exactly array holds? Array simply holds a collection of similar types of data. A very simple way to explain this, right? So what it can do is, earlier, if we were using variables in your computer memory, right? Different variables, for example, variable 1, variable 2, variable 3, variable 4 were kind of spread across all over the computer memory at different locations, right? But what we do in array is, in array, we have certain blocks of contiguous memory allocated, right, which can store all these students. Now, for example, if I want to store 100 people or store the names of 100 people, then what I can do is I can simply create an array of strings, because the names are always in the form of string, right? And since I want to store the name of 100 students, I will just mention 100 over here, right? And this is how I will be able to store the name of 100 students, okay? Just remember that when I write 100, I am kind of restricted over here. I will not be able to store more than 100 names, okay? The number of values in this array is now fixed and can never go above 100, okay? And in computer memory, what exactly happens is, right, there is a contiguous set of memory locations which is now kind of allocated to an array, okay? Instead of sparse spaces and distributed spaces for variables which is spread across all over your computer memory, what happens is we have contiguous memory locations allocated. In a simple example, for example, if this is a space which is, let's say, at address 200, right, this is a space which will be at address 202. For example, if it takes 2 byte of space, this will be 204, 206, and then 208. Okay, so this is how in arrays you're doing again the same thing. In computer memory only, you're storing your all the names of the students, just that all those names now are placed in contiguous memory locations. How will that help? Right, we will quickly see that as well. Okay, but let's talk first a little bit about the syntax as well, so that from the implementation perspective also we are a little bit clear. Okay, so what happens is, how do you really declare an array? You basically mention the data type. You mention a square bracket, right? And then you mention the array name. Okay, like if there is a variable name, okay, and if I put int in front of it, it kind of becomes very clear that this variable can only hold integer values. Similarly, when I do string an array, right, that means that array can only hold string values. It's homogeneous in nature. The array will only be, for example, Ria, Akash, Akhil, like this, and everything has to be string. I cannot store 25 or 26.9 in this. Okay, so remember, arrays are homogeneous in nature. If I make an array of string, it could only hold string values. Okay, here when we mention the data type could be any primitive data type, right? It could be int, it could be char, it could be double, and so on. Okay, and also an array of objects, which is non-primitive data types, right, which we have not really talked about in detail, but know that an array of objects can also be created. Okay, and here this array name is nothing but identifier, which is like a unique name to identify that particular array. Okay, so this is how you actually create an array. Example would be double. Square bracket, data, right? Here data is an array that can hold values of type double. Okay, now this is how you declare an array. But another question that can come is that at this point of time, how many elements can it hold? If I create an array like this, how do I know how many elements can it hold? Okay, so that's a very good question. To actually define the number of elements that an array can hold, we have to allocate memory for the array in Java. Okay, I'll write that down as well. To define the number of elements that an array can hold, we have to allocate memory for the array in Java. Okay. For example, if I do this, right, this is called declaring an array. Okay. And when I do this, one second. When I do this, new double 10. Okay. Now this is called allocating memory. All right. Here, the array can now store 10 elements. We can say that the size or the length of the array is 10. Okay. In Java, you can actually do the declaration and allocation of the memory in a single statement as well. For example, if you will do this directly in one plain single line, that is also fine as well. Okay, so this is how exactly you create an array. Okay, next, let's also quickly talk about, before we move to the implementation, how do you initialize an array? Okay, know that when you do new double 10 in your computer memory, you basically have 10 spaces. Like this. Okay, these are the 10 empty slots which have actually been created, which can only hold values of the type double. Okay. Now over here, let's say there are two ways to actually put values in the array now. All right. One way to do is, let's say you put the declaration and initialization in one go, right? So that means you can initialize the array during the declaration itself. For example, you could do int age is equal to 12, 4, 5, 2, and 5. Okay. So over here we have created an array which is named age, and we have initialized it with the values which are present inside the curly brackets. Okay. Note that over here, we have not provided the size of the array. In this case, the Java compiler automatically specifies the size by basically counting the number of elements in the array. Okay, it automatically counts itself. Again, the other process is, in the Java array, each memory location is associated with a number. Okay. Now, a very common question that comes is, okay, in variables, what happens is, I have variable name1, I have variable name2, I have variable name3, right? Now, every value has a different variable name assigned to it. So it is very easy to access the values, right? If I want to, let's say, get the name, okay, over here, let's say it's Rahul. If I want to get the Rahul names, I will simply call name2, because that is a unique variable name for Rahul as a string. But here you will see a lot of numbers over here are being associated with one common name, age, right? Which is one common name of the array, right? So how do I access this particular value, let's say 5, okay? Or how do I access this particular value 12, right? Because here there are no different names for different I would say positions or different numbers, right? So the idea is, when you're dealing with arrays in Java array, in each memory location is basically associated with a number, okay? Each particular memory location is associated with a number, okay? That number is known as an array index, okay? So we can also initialize, the other way to initialize arrays in Java is by using indexes, okay? For example, the other way to create an array could be int age, new int 5, and then you could do age of 0. See and focus on the syntax over here. 12, age of 1 is 4, age of 2 is 5, okay? And so on. And how does it really look in computer memory? Is like this. Let's say I did 12, 4, 5, 2, and 5. Okay. So age of 0 is this. Remember the indexing, like I said, each value in the array is basically associated with a number, and that numbering starts from 0. So 0, so although the entire name of the array is age, right? If I have to access individual values, I do it through indexing. So age of 0, if I will do, that means the very first value of the array is going to be 12. If I will do age of 1, that means the second position in the array will be occupied by 4. Okay, remember the counting does not start from 1. The counting indexes in arrays always start from 0. That means the first element of an array is at index 0. Okay, so that means if, let's say, the size of the array is 5 over here, the indexing will run from 0 to 4, right? Because the counting starts from 0. So if I have to store 5 elements, the counting will run up to 4. Okay. So if the size of the array is n, the indexes basically run from 0 to n minus 1. Okay. So this is how the basic indexing runs through, right? And if, let's say, now I want to access this particular value, this value is the 4th element of the array, so it will be present at the 3rd index. So if I will do ARR of 3, this will basically give me the element 2, right? Because of the concept of indexing, where the counting starts from 0. So this is how, in a very simple manner, you can actually not just store the elements in contiguous location. You don't have to remember hundreds of variable names. There is just one common name of the array, which is age. And by using the concept of indexing, you are able to access the individual elements of the array. Okay. And these are all in your computer memory, stored in one contiguous location, compared to the concept of variables, which are occupying random accesses in the computer memory. Okay, because they are in, I would say, proper contiguous location. For computer memory, it's easier to access as well, right? For example, let's say I am storing characters, okay? And let's say the starting address is 500, right? And I want to, let's say, address or access the 3rd element of the array, right? That means it will be present at the 2nd index. I know each and every place occupies 2 bytes, for example, right? So I can simply do that calculation over here that I want to access the second element. The starting address is basically 500, right? So if I do 2 into 2 over here, because I want to access the second element and each one occupies 2, right? So simply the address is 504, which will have the third element of the array, right? So computer memory just basically knows the first initial address, right? And using the concept of indexing, right, and the space occupied by each and every position, it can easily calculate the values or the elements at the other position. So this is how, by using arrays, you can store similar type of data, a lot of it together in one single place. Just that it's only constrained by the fact that, for example, here I'm storing 5 values. In future, let's say I want to store 7 values, then this array is not usable because it's fixed in size. The moment you mention 5 over here, you can never change it, right? It will always remain the same. You can store less elements if there are, let's say, 5 space you allocated, but you do want to only store 3 elements, then you waste 2 spaces, that's fine, but you cannot store 6 elements. And this is how the basic construct of arrays is really built. Clear to everyone? Then I'll take some doubts if there are any. Dheeraj says, is double a class also? Double is a primitive data type, Dheeraj. I just wrote over here as well. Okay. Anmol says, difference between this and this. Anmol, there is no difference. Feel free to use whichever syntax you like. Okay. Right. Now, if this is clear, I'll kind of jump a little bit and talk about how does, this works and how does the overall concept work in terms of implementation as well. Tony says, how can we initialize dynamic array? As such, Tony, by default, there is no concept of dynamic arrays, right? We have array list present, which have array list. We have array list present in Java, which kind of shrinks and grows in size automatically, right? But even array list internally uses array only, right? It's just that you don't see that implementation, right? But internally it's using an array only. But yes, if you want to kind of take the visualization of not defining the space and being able to add and remove elements as per your wish and not defining the space in the start, array list is what we do and talk about. And this is going to be covered in the next classes. Dheeraj, new over here is just for space allocation. Okay. No matter what data type is present over here, you mention string, you mention double, or you may mention object. Okay. New stands over here for space allocation, that you want to allocate some memory. It's not dependent on the data type. Okay. New just takes care of space allocation for this particular array with this size in the computer memory. The concept is not at all related to what data type you are mentioning over here. It could be anything. All right. Okay, so now that we've taken like a quick glimpse on how does concept of arrays really work, would be a good time to go and start taking a little bit demo and see how exactly everything is working as well, and how does everything looks when we actually jump onto the implementation. So I will create a new package, L7, that's right, maybe. New array class, array demo. All right. So let's say I do this. I create an array of size 5. Okay. Now take a guess and think of what will happen if I do this. What do you think will be the output? Any guesses? All right, let's see. All right, let's see. So over here, I run this. And you can see something like this is appearing over here. Okay. Now let's try to demystify this a little bit, what exactly this means. So you see a square bracket in the start. Okay. That means that you are basically trying to print something which is related to an array. Okay. I means it's an integer array. So that's why I stands for. At the rate means after that, whatever is present is basically the address of the array. Okay, so this is the entire meaning to it. Repeating it one more time. Square bracket means that this is an address for an array. I means that the array is an integer array. At the rate and after post at rate, what is written is basically the address of the array, or maybe the address of the very first location. Okay, so this is a good question, sometimes asked as well. Make sure you know this. So this is one syntax to initialize an array. The other way to do that would be like I showed in the start, that you could be using 2 different lines to do the same as well. Anything works. Okay. If you want to do the declaration and initialization in the same line, that is also fine. 2 different lines, that is also fine. Doesn't make any difference. Okay. Next are a few functions which are associated with an array. For example, I do arr.length. This will basically give me the size of the array. How many elements or how much space is allocated to that array, which is 5. Okay. Next is, let's say I want to get the elements of the array. Okay. One way to get the elements of the array is to go to each and every index. So ARR of 0. Then you can do ARR of 1, ARR of 2, ARR of 3, ARR of 4. And you can see initially, because no space has actually and no elements are actually present in the array, and it's just all empty spaces, right? Just that the space is allocated, but no element is stored, right? You can see that all the values are by default 0. Okay, so these are how you get the elements. Let's say this is, let's say we also see how do we set elements in the array or how do we update the elements of the array. Right? If ARR of 0 is 10, that means at this very position, you will now instead of 0 have a 10 at the very first position because it's ARR of 0. Again, 0 based indexing. Then let's say I do 20. Two, 3, 4. Okay, so let's say this is 30. 40, 50. Now, if I do this again, after putting some values in the array, if I do this, you can see now the values are there. Take a guess and see what would happen if I now do this. If I do ARR of 5, correct. It should throw an error, and you will also see that the error you get is actually very readable. Okay. It says array index out of bound exception, right? It says you created an array of size 5. So if you think logically, the possible indexes are only 0 to 4. So how come you're trying to access an index which is not there at all, right? So it says index 5. It is out of bounds for an array of length 5. So this is an error. Okay, this is not valid. Similar is the error you will get if you will try to put something on that position as well. Okay, now another thing is I'm doing some operation. Okay. And I'm seeing a lot of redundancy in that operation, right? A lot of the part of the operation that I'm doing is very same with a one small twitch. And in these situations, what do we use? We actually use for loops for doing a single task again and again. So instead of actually, if let's say there are 500 array values, instead of doing this process, I can essentially just use a for loop for the indexing, which is starting from 0 up till the very length of the array, less than the length. So remember, this loop will only run from I is equal to 0, I is equal to 1, 2, 3, and 4, because I always has to be less than 5. Okay, now in this case, what will happen is, so I can try to optimize the type work I just did. Instead of writing all these lines again and again, I can just simply do this. So this should also print the values for me over here. And you can see it indeed did. Okay, but in a far, far better format, right? So this is how I am starting from the very first index of the array and going towards the end. So if there's array size is 5, I'm doing I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3, and I is equal to 4, right? I'm going from start to end. You can do probably the opposite as well. For example, you want to print the elements from end to the start. So the very last index of the array will always be 5 minus 1, 4. I can do I greater than equal to 0 and then I minus minus. So this will basically print the elements from end to start. You can run this as well, and you can see elements 50, 40, 30, 20, 10 are printed. Okay. Another type of loop is also used, which is slightly optimized loop. You might not feel completely comfortable with this kind of a syntax in the first go, but eventually you will realize that when you will, move to like very hands-on, you'll get very hands-on with coding, you'll actually prefer this syntax. There is a concept known as enhanced for loop. Okay. So enhanced for loop is basically, again, just for reading the elements only, but it's like slightly more readable in future. So what happens is, here you are going over each and every index and then just printing the element or accessing the element at that index. Enhanced for loop goes one step further in this. You do this. Okay, so what's exactly happening is, now over here, val is not actually an index. When you use enhanced for loops, val is directly that element only. So this kind of a loop does not work on the concept of indexing. For example, here you have elements 10, 20, 30, 40, and 50. Val is simply a variable which is accessing first this element, then automatically val moves here, then automatically val moves here, then automatically val moves here, and then automatically val moves here. Okay, so this is a slightly shorter and a faster way of writing enhanced, or that is why it's called enhanced for loop. Remember, it can only read the values over here. Okay. Two things to remember about enhanced for loop is, like you just saw, in a normal for loop, you could move forward and you could also move backwards. In enhanced for loop, you only move backwards. If I want to read an array from end to the start, I want to move backwards. No, enhanced for loops can't really do that. Okay. Secondly, if I want to, let's say, update a value, right? If I want to, let's say, change all the values in the array to 200, right? I can use a simple for loop over here for that. Enhanced for loop cannot do any update operation. Enhanced for loops can only do read operation. So they are only for reading the elements of the array. If you want to use a loop which will update all the elements of the array, enhanced for loops cannot do that. Okay. So this is also very important, and trust me, enhanced for loops are very, very popularly used, and they do make your code very, very readable. If you want to see a quick output over here as well, you can see it does the same thing, but just that the syntax is slightly more readable, which you will become comfortable with as and when we move forward. Okay. Next thing over here is, for example, I do this int ARR1 is equal to ARR. Okay. And then I do ARR 1 of 3 is basically equal to 100. Okay. And then I do ARR of 3. Now take a guess and think what will be the output. Is a new array created, or ARR1 is pointing to the same array, or ARR1 basically created a copy of ARR and then kind of did something. Initially, in ARR at the third index, we ideally had 40, right? Now, what do you think would have happened? Okay, Harshdeep says that the previous value will be retained and the output will be 40. What about others? Quickly in the chat. Venkat also says no changes will happen. All right. What about others? All right, let's see the output. See the changes. See, you will see when I run this code, in the output, you will see that the changes happen. So what actually happened is you had an array over here, right? So the moment you do int ARR1 equal to ARR. So what actually happens is no new array is actually created, right? Till the time you have just done this, right? This is nothing but a reference over here. And the moment you do this, it is nothing but pointing at the very same address. Okay, so ARR1 is also pointing over here. Both are pointing at the same location. Now, both are basically in a position to do the change. So when I do ARR1 of 3 equal to 100, this change basically happens. And you can see it is getting reflected as well. And now when you will print the array, you will see that the value 100 actually comes over here. Okay. So this is how you can actually know that when I do this, you actually are now ARR1 and ARR. Both are now kind of referencing towards the same axis. It's not like a copy has been created and now you're pointing to another location, or a reference or anything like that has not happened. Both are pointing at the very same position. Okay. Now, what we'll do is we'll take a bunch of more examples over here for a similar concept, and then kind of, deepen our knowledge of this concept a little bit. And then if there would be any doubts also, it will get cleared. Let's say I do int I is equal to 0, int j is equal to 2. I do this ARR of I. Let's say I comment this out for the time being so that you know what exactly the arrays are. Okay. Let's say I call a function. Let's say I do this over here, right? Now think about what would be the output in this situation. What about others? This actually has to be this. Sorry, my bad. And this will also be just int temp. Okay, let's see. So initial values are 10 and 30 at this particular position. Let's see, did I do something? One second now. Okay. All right. So let's see what really happened and how come the output is of this way. All right. So over here, what happened was int I is equal to 0 and int j is equal to 2. So the values are 10 and the values are 30, right? Now see, when I print this, the output is 10 and 30, which is absolutely correct. This should be the output. Now see, when I call the swap function over here, you will see it's not really a matter if array would have been here or not. When I do ARR of I, I'm actually passing the element 10, correct? Even if I just write 10, or if I just actually create a variable 1, which passes 10, right? It does not really matter, right? Although you are taking arrays over here, but what you are eventually trying to pass down is an element, right? Which is ARR of I. So that is why when you do ARR of I over here, simply the element 10 goes. And that is why you have 1 as a variable, which takes up 10. Okay. And 2 as a variable, which basically takes up 30. So what happened was, the moment you call ARR of I and the moment you call ARR of J, right? What really happened over here was, in the swap function, you actually had 1 and 2 written over here. So when you do this, so actually 10 basically got passed over here and 30 basically got passed over here. And these are two local variables bounded to the function. So when you do temp is equal to 1, 1 is equal to 2, right? And 2 is equal to temp. So simply these variables took a different value. Nothing actually really changed in the original array. And that is why you have the same output retained. Now let me show you another example that will kind of help you to understand this concept even better. Right? I'm just going to write the same swap function, but it's slightly differently. Okay. Now what I do is this. Just for better clarity, I will maybe print a statement here as well. Now guess the output for this situation. This much. You will automatically understand when I give 1 or 2 more examples that what exactly is happening. Okay, now let's see as well. Maybe let's also put a proper bifurcation in case you guys would want to, revisit these notes in future. Okay, let's see. Now what you will see is the swap has actually happened. Let's see what really did over here. When you do ARR of I and J, it's pretty much the same, 10 and 30. Then you call the swap operation. See, over here, no element actually has been passed. Just the two values, I and J, have actually been passed. Okay. And I just showed you this example where you will see the same thing has happened over here as well, where A, when you pass ARR, right? And when you do this, no new array has been created, right? Or no local array has been created, right? The moment you do, this is nothing but doing int of A is equal to ARR, right? And remember that everything in Java is passed by value. Just in case of array, which is nothing but an object only, the array reference is actually passed by value. Okay, the array reference over here. So when you actually pass an array to other method, actually the reference to that array is copied. Okay, remember, when you ever pass an array to any other method, right, actually the reference to the array is passed. So actually the reference or the address of this array is passed, and now A is also pointing at the very same location. That is why it's like ARR was there. Now A is also pointing over here, and that is when you actually now try to do the swap, it actually retains and the swapping actually happens. So when you actually pass array, right, it is being passed by reference to the other function, and any changes in the content of the array through that reference will actually affect the original array as well. Okay, so this is an example where you see that actually the swapping happened. But in this case, nothing really happened. You just passed two values, 10 and 30, which kind of retained themselves locally. Let's see one more case. Now think what would be the output in this situation. What do you all think? It's mentioned over here, right, Bobby? And we just saw the similar syntax as well in the start. Okay, let's see. See, in this case, nothing happened. Okay. Now let's see what really is the reason. When I do int other is equal to 100, 200, 300, this is nothing but an array of size 3. Okay. Now, when I try to print the values, right, it simply gives me 30 and it gives me 100, right? Which makes sense. Initially, if you would want to take like a scenario where nothing has been swapped, let's say you do this because we swapped, that's why 10 and 30 swap, but ideally it's 10 and 100. Okay. So over here, now the next thing that has happened is you basically called the swap function. Okay. Now, when you call the swap function, you basically pass the arrays ARR and then you pass the array other over here. So there is an array. Then there is other. Okay. Now over here, what happened was when you call and the swap function over here, it is being passed and 1 and 2 are basically pointing over here. 1 and 2. Okay. Now what happened was the moment you do int temp is equal to 1 over here, right? The moment you do int temp equal to 1, what happened was now I have temp also pointing over here, right? Temp is now also pointing to 1. Okay, right? Now 1 as a pointer is now pointing to 2. Okay. Right? And 2 is now pointing to temp over here, right? And the moment this function finishes, the existence of 1 and 2 goes away and temp also goes away. Temp goes away, 1 goes away, 2 goes away. Did we do any change in the array? We just played around with 3 pointers a little bit, 1, 2 and temp, right? We never really changed anything where ARR and other were pointing to. That is why when you came out also, the values were still 10, the values were still 100. I'll show you one more time what happened. Let's say we keep it side by side. These are very important concepts. You had ARR, you had other, right? When you passed references, 1 is now also pointing to ARR. Okay. Right? And then 2 is pointing to other. Okay. And then temp is pointing to 1. Okay. Temp is pointing where 1 is pointing. Now 1 is pointing where 2 is pointing. Okay. 1 is now pointing here. Now 2 is pointing where temp is pointing. Okay. Now 2 is pointing over here. Finish. Last line. This function finishes. The existence of 1, 2 and temp goes away. That's it. Now we come back. Has ARR and other even moved a little bit? No. ARR is still pointing to the original array. So when you do 10, it's still printing the value 10. When you do other, it's still printing the value 100. And hence the values printing. Okay. So these are all 3 very good examples. They are asked very frequently in aptitude rounds and MCQs as well. So make sure each and everything makes sense. समझ आया सबको? हुआ क्या यहाँ पर? Everything is now, everyone does understand all these cases. I always tell all these examples in the class so that after the class, you don't have any confusion as to what is happening in which. Is everyone absolutely clear? Awesome. And this kind of completes our theory for understanding arrays. If you have any questions, if you have any doubts, now is the right time to ask, because after this, now we'll jump on to problems and start solving questions. सबको clear है? मजा आया पढ़ने में? समझ आया सबको? How all these examples are working? How does array work? What's really the concept? So remember, everything in Java is passed by value. Just that arrays, which are nothing but objects, they are passed by reference. So when you pass one array to another array, you actually pass the reference of that array and not really just like the elements or anything. Okay, then let's take a quick 5 minutes break. Come back and then let's start solving questions. Okay. No, Akshat, there is no concept of and star like you have in C++. Nothing is applicable over here. Okay. That's why Java is actually considered slightly easier also, because we don't have the concept of pointers and allocators or anything like that over here. Okay. All right. Let's meet at 10:10. All right, everyone is back. Okay. Now that we have taken a good look at the theoretical aspect, okay, the theoretical aspect of how does the concept of arrays work and what exactly are arrays, now would be a good time to actually start solving a bunch of questions also, so that we can get comfortable with the operations as well. Okay, so the first question would be to reverse an array. Very simple. You will be given an input array like this, right? And the output should be this. So all the elements should actually be reversed. Okay. If this is the starting element, 10. Now the starting element of the array should be 50. Okay. So you have to do the complete reverse. This is your first question. Take a few minutes, try to solve it on yourself once, and then we can discuss the solution together. No, Akshat, I have been saying that the same thing. Array Java is always passed by value except for arrays and objects. Take 3-4 minutes, max 5 minutes. We'll not take more than that. Okay. And then we will start discussing the answer for the question, reverse an array. No, you do not have to use an extra array. You have to make changes to the original array. Guys, please only send answers in the private chat. And if you have an approach, you can send the approach first and then the final solution. Please don't send answers in the comment chat. Jatin, you are just printing the elements in the reverse order. I want to do the actual change in the array. Yes, Akshat, you can do that. I am not sure, Dheeraj, this is very incomplete approach. Probably send the entire answer or maybe a code that you've written.
Is this working, Arjun? Have you run this code?
Okay, yeah, correct. Yeah, this will work. Perfect. Okay, then I hope everyone has given a try. Let's see how we can solve this question. Okay, although there are multiple ways to do this question, right? Feel free to use the approach that you're comfortable with, right? But overall, the idea was that given an array, you have to reverse the array and you have to make sure that the reversal actually happens in the original array, right? You do not really use other arrays or any other array to do this. A very simple process to do this would be, for example, I have this array 10, 20, 30, 40, 50. Okay. And now I will use two variables. So over here, I and j. I would point towards the very first element and j would point towards the very last element. And what I will do is I will simply swap the values present at these two indexes. Okay. So because of which 50 would come over here and 10 would come over here. And then I would move the I pointer forward. I would move the j pointer backward and do again the swap operation. Because of which 40 would come over here and 20 would come over here. Okay. And I will keep on doing this process till the time I and j are not pointing at the very same position. At this point of time, you can see I will do again the swap operation, which will not do nothing but swap 30 with 30 itself, right? And then moving that, when I move forward, j will move over here and I will move over here. And at any point of time where j becomes greater than I is the point I actually stop and don't do any more swap operation. Okay, so this was simply what you could do. Let's see as well. $20, $30, $40, and $50. And let's say I call the reverse function. Always try to use the power of functions because they will come very, very handy. Let's say I also write a display function. And once I have done the reversal, I again use the display function. So first, this function does nothing but print the element, prints the element from start to end. Okay. Then I will write function where I will take two pointers, one at the very start, one at the very last element. Okay, until the time I is less than equal to j, what I will do is I will swap the values at these places. And then I have to move, once after doing this, I have to move I minus minus and I have to move j backwards. Let's see. And you can see initially the array was this. For a better representation, what we could also do is this, just for like slightly better visualization of code. You can see initially the array was 10, 20, 30, 40, 50. When I call the reverse function, post that the same array is now 50, 40, 30, 20, and 10. Applying the very simple approach, taking 2 pointers, one from the start, one from the end, and moving them towards closer to each other. And while doing that, also trying to reverse or swap the elements. This is how you solve the question, reverse an array. Clear to everyone? Okay, next question. Again, very simple. Let's say you are given an array. Find the maximum element of the array. For example, if the array is or array could have any elements. So in this case, the answer is going to be 1. Okay, so this is minimum. If you have to find maximum, like the same concept goes, let's say we do the minimum only. Okay, for maximum, it would be 9. For minimum, it would be 1. So given an array, you need to find the minimum element of the array. Okay, so this is the array and the answer is 1. Now think of how would you solve this question. Bobby, that's a little extra which we don't have to do. Like, it's unnecessary complexity what you're suggesting. Try to do something better. That is fine, Venkat. All right. All right, let's see how we can do this. Again, there are multiple ways to do this, and feel free to use the way which is more preferable to you. So you have to find the minimum element of the array, right? Now, the minimum element could literally be anything, right? It could be minus 100, right? Any possible, the least minimum value or the maximum minimum value is possible over here, right? So the minimum value is minus infinity. So it could actually be anything, right? So what we do is, when we have to find the minimum element of the array, we actually initialize it with the largest value, and then we try to, decrease that value as much as we can, right? Or you could actually initialize it to the very first element, or the first element of the array as well. For example, probably like, so you could do int minimum. Either you could do this integer dot max value, it will give the maximum possible integer value to min variable, or you could do this as well. Anything is fine, because when you already initialize to ARR of 0, you do have a certain range in mind. Okay, now the process is very simple. Right, you do if ARR of I is less than the minimum so far. The value you just saw is actually less than the minimum I already have. That means I got a better minimum, right? In this case, minimum will now point to ARR of 1. Okay. And by the end of it, you can actually just print the value in the min variable. This is for minimum element, my bad. If it would have been maximum element, you would initialize it to integer dot min value. I did not call this function. And you can see the minimum value is indeed 10, and that is the answer as well. Okay. So this is what, or this is how you basically find the minimum element of the array. Puneet says integer dot max value or this, which one is better? The safer, although Puneet, in basic cases, both would work. Some people try to use 1e to the power 9, not 10e to the power 9, 1e to the power 9, because integer dot max value is actually at the very limit of the overflow, right? So if you're not thinking well, you might end up with something which kind of may give you an overflow condition. 1e to the power 9 does not give you that. All right, clear to everyone? Can we move to the next question very quickly?
Have you tried running this solution, Akshat? If you will run it, you would know. But yes, overall, the solution looks good. Okay.
Perfect. Now that we've done good two problems, let's quickly move to the next one, slightly on the medium's end. Okay. Perfect. So now what you have to do is you have to actually rotate the array. Now, what would that mean? For example, I give you this array and I also give you a rotation factor 3. Okay. The rotation factor 3 means everything needs to be rotated by 3 steps. Okay. Because of which, what would happen over here is this will be the situation. So I am rotating. Okay. Make sure you do follow that ordering over here. Okay. For example, if I do the same array, k is equal to 2. So in that case, you would simply have 1, 2, 3, 4, 5. So this is another example. Remember, the value of k could be anything. For example, I could also give k is equal to -2. So in that case, what will happen is 3, 4, 5, 1 and 2 will be your output. So there could be negative rotation also. Okay. And I could also give a value, let's say k is equal to 6. Okay. So if you will rotate the array 5 times, right, what will happen is you will reach to the original array only. So when you will do the 6th rotation, this will happen. Okay. So these are all the possible outputs. So you have to do the rotation where any kind of rotation value is possible. Now try to think of how would you try to solve this question. Question is clear to everyone, right? Anyone who's unclear about the question? Yes, no. Guys, do you understand the question or do you not understand the question? Or am I not audible? Everyone. Great. Okay. Start thinking. Okay. So if the rotation is positive, the elements are moved forward. If the rotation is negative, the elements are rotated backwards. And you can see multiple examples over here to understand the pattern.
Akshat, it will show you the line number exactly where the error is, and you can see, check what exactly the error there is. Yes, you can. Dheeraj. Yes, you can use extra memory. Bobby, what will you do, for example, in this question, if I will give you a value of k is equal to 20? Do you think your solution will work for a value of k is equal to 20, or maybe a k value minus 1000? Again, Puneet, do you think your solution will work for a value of k is equal to 2000 or k is equal to minus 500?
Harshdeep, do you think your solution will work for a value of k is equal to minus 20? Or any negative cases will your code will work? All right, let's see how we can do this. Okay, so for this question now, what you will realize is that there are a few important things and cases we need to be careful about, which is when the value of k is very large or value of k is negative. But even for that, there is very simple thing that you had to do. Okay, let's take an example. Let's say the original array, when the k is equal to 0, is this. Okay, let's say I do k is equal to 1. So it becomes this. If I do rotation twice, it becomes this. If I do this, it becomes this. If I do this, it becomes this. Okay. If I do this, it becomes this. Correct? Now let's say if I do minus 1, okay, it basically becomes this. If I do k is equal to minus 2, it becomes this. Correct? So these are a few cases that we can see over here. Okay. Now let's make a few observations. Can I say, or if I take this, let's say even further, can I say that the answer for this case, and this case is exactly the same? Yes. The output for k is equal to 0, k is equal to 4, and k is equal to 8 is exactly the same, right? So no matter what big value you actually take for k, can I just say that whatever the rotation factor is given, if I just do a mod of it by n, which is the length of the array, the answer will exactly always be same. Why? Because similarly, you will also see that the output for k is equal to 1 and k is equal to 5 is also same, which means that, and which kind of means that when you do 1 mod 4, the answer is 1, and when you also do 5 mod 4, the answer is 1, right? So if I give you, let's say, a rotation of 20, and if I do a mod 4, it is nothing but rotation 0 only. If I give you a rotation value 35, okay, 35 by 4, right? It means nothing but the same rotation which we have already seen. Is this, I hope the first case is clear to everyone, how to deal with very large values of k? Clear to everyone? All right. Now let's see for the negative cases. Now, even for negative cases, it was very, very simple. Don't you think the answer for k is equal to -2 was actually equal to k is equal to 2, which is nothing but -2, which is the value of k plus the length of the array, okay, which is nothing, -2 plus 4 is equal to 2. One more example. Don't you think the answer for k is equal to -1 was equal to k is equal to 3, which is nothing but -1 plus 4, -1 plus the length of the array? Yes. So even that cases are reduced. So let's say if someone gives you the value 33, right? You will do nothing but 33 mod 4, which is nothing going to be 1. Okay. Let's say someone gives you -20. Okay. Even in that case, you do -20 by 4, or let's say I do -22, right? Which will give you -2, right? And then now this is reduced to a value between 0 to 4 and 0 to -4, and then just to -2 plus 4, which is equal to 2, which means the rotation -22 actually gets mapped to 2. This is the part we only do for negative numbers. For example, the value is 40, 50. Okay. 50 mod 4 will give you 2. So it's since this is positive, you already know the answer, right? But let's say I do -27. Okay. First, you again do the mod. That part is same. This will give you -3. Since this is negative, you need to add 4 to it, which will give you 1. That means -27 actually gets mapped to 1. So all the possible answers are this only. These are all the possible rotation answer, right? And nothing can happen except for these. You just have to make sure the other values basically get mapped to these rotations. So this is how, first of all, you tackle the case of very large negative and positive values. Itna part clear hai? This is clear to everyone? Quickly just keep writing yes in the chat that I know it is clear. Perfect. Now that you know how exactly it works, right? Now you have to do the rotation part, which was absolutely easy, right? Let's say you have the array this, and the value of k is equal to 3. Okay. So you will have to basically do 3 rotations. So understand that always the outer for loop will only run from the value of 1 to k, which is or 1 to length of the array O of n. Okay. So what I will do is I need to do the rotation 3 times. The value of k is equal to 3. First, I will work on the concept of k is equal to 1. What does k equal to 1 actually mean, right? We will simply take the last element of the array, which is what? 4. Okay, we store it somewhere. And what we do is we start shifting the elements by 1 position. Okay, I start the loop over here of I will put this particular element, okay, over on a particular position where it needs to be shifted. For example, if this is the element, it needs to be shifted, or you can maybe run the loop from here as well. This needs to be over here. This needs, like, whatever is present at ARR of I, it will go to I plus 1. Okay. Now you come here, put it over here. Now you come over here, put it over here. Okay. And just take the very last element, which was 4, this was, and just place it in the front. Okay. Now let's say you run the other for loop now and try to do the same thing over here now. Again, this is your array that you are considering. Again, take the very last element, which is what? 3, store it in a temp variable, and again do the same thing. 4 goes over here, 1 goes over here, 2 goes over here. And then this element comes at this position. Okay. Now this is your array. The k value is 3. So do that for the third time. In this case, what will happen is over here, you will have again the first value, last value, sorry. The last value stored in a temporary variable because it will get overridden, right? Because the moment I put 1 at this position, 1 comes over here, 4 comes over here, 3 comes over here. And the very first position, you will simply use 2. And by the end, you come at the end of the loop, you will basically have the third rotation completed. Okay. And this is how simply you can do the rotation of the elements of the array. Clear to everyone? Okay. Try writing the code for this on your own. It's very, very easy. I will just also still give you a pseudocode for this as well. This will be a simple rotate function. You will pass the array. You will pass the rotation factor. Now, whatever is the rotation factor, whatever is the rotation value, doesn't matter. Always take its mod. K is equal to K mod length, right? And if even after doing this, the value is less than 0, then do K is equal to ARR.length, right? And post this. Once you're done with this, now your range is absolutely correct. Now start with the very first rotation, go up till the value of K and do I plus. Okay. And after this is very easy. Just take a temp variable, which will store the very last element of the array, and then just run a for loop. Whatever is present at, let's say, ARR of I, it will move to ARR of I plus 1. Okay, or any order you prefer, you can use. And in the end, once you're done with this, just place this element, this temp element at the very start of the array. Okay, either you can use this or you can use this also if you're moving from the ARR of I minus 1, but this is the case where the loop runs from end to start. Any way you prefer, you can use it, right? But just make sure that the rotation actually happens, right? So this is a good question, although not very difficult, but most of the students do get confused in the very first part, right? Where they have to kind of deal with very large and negative values of K. Once you figure that part out, post that, it's not a very difficult to solve this question. Okay, so make sure you understand this concept right? And see how it actually works. You understand the concept of rotation and you'll be good to go. Clear to everyone? And with this, we conclude our content for today's class, where we talked about the basics of sarees and solved a bunch of questions based on that as well. If now anyone has any questions or any doubts, now would be a good time to ask. No questions? Everything is clear? इतना अच्छा पढ़ा क्या हमने? और कुछ भी समझ नहीं आया तो there are no doubts. Which way is it? बताओ. Understood, not understood? Harshdeep, Jatin, Narendra. There is no thinking process over here, Venkat. This is pure observation. You go, you see a bunch of, you try to see a bunch of rotations. You observe that for a lot of them, the answer is same. And then you kind of work on the same idea. अक्षत खुद लिख के देखो एक बार, फिर रेफर करना. Try once on your own. If you face any doubts, post it in the TA doubt section and I'll help you out. Yes, Venkat, I will be sharing those homework problems on the platform itself. Okay. Any other questions to anyone? Please make sure you solve all the homework problems and understand all of them as well. In case if you have any questions, I'll be happy to take those up. Perfect. So we are good in the journey of arrays now, right? In the next session, we'll solve a bunch of questions. We'll also talk about array lists a little bit and how does the concept really work around that. Yes, we have not discussed that, Venkat. We can discuss that in the next class. It's very easy. You just have to put the scanner statement in a loop. If you want, I can give a demo in the next class, or I can also share it in the chat as well and Discord so you can refer it. Anyway, it's fine. Okay. Chalo, all right then. I hope everything is clear to everyone. Thank you so much for attending today's session. I will see you in the next one. Thank you. Thank you so much for attending. Bye-bye. Good night. Have a great week.